Okay, welcome back. And in here, we're going to do some more math, a little more advanced. First of all, I want to take you to this revised math main. Besides just adding numbers together, you can work on variables together. So for instance, c equals a plus 2. A has been defined already as 10, so c is going to be 12. D is a times b. Well, that's going to be 10 times 5. That'll be 50. So your expressions can always have other variables included in them. Then there's this set of shortcut expressions in C. These are optimized little shortcuts that are often useful. They don't need to be used though. That can save you a bit of compiling time. First of all, a plus plus. That's exactly the same as saying a equals a plus 1. Or b minus minus. That means the same as b equals b minus 1. So a is 10, so this is now a is 11. And here b was 5, so b would be 4. There's even somewhat slightly more complicated expressions. Plus equals means take the value of c and add 5 to it and put that new value in c. So c we said was 12, and we're adding 5, so c will be 17. D says is times equals. Take whatever D is now and multiply it by 3. Put the result back into the memory position of D. Another little thing before we continue. /n/r are formatting comments in printf statements. And this stands for new line return. So when it prints once, it goes back over to this side. Before we had the lines printing across. This is just a nice bit of formatting to use. So let's debug this and see what we get. So it's built, and here's our output. And you can see our values. For some reason, the A hasn't shown up here. Let's stop this and try it again. There's the A. Okay, so what we said about the values. Now we want to look at some of the specialized math functions in C. On your calculator, you can take the sign of a number, square root, you can raise numbers to a power, and do exponentials and the like. Those functions and more exist in C. They're in a library called mathh.c. So this is a library that the C compiler comes with. In the appendix of the manual, you can find the available math functions. So here we have down here sine. Remember, sine is of an angle in radians. Square root, power, that's the same as 5 raised to the power of 3. And log actually is the natural log, not the base 10 log. These will all produce floating or decimal numbers, so we've defined the variables as floats. So let's debug this and see what the output is. Okay, so let's go to the window, and you can see the numbers that is printed out. Now, one of the things we notice is 5 to the power of 3, that's 125. Notice there's a certain amount of error in this number, and that's because of the size of the variables. Now, we can go to the project configuration window, and we can come up to the linker and the memory model, and these are 32-bit. I'm going to change them back to 24-bit just so that we can see what happens to the results. Okay, now we do this again. And we come to the UART window. And you can see that the results are somewhat different from what we had before. And this 5 to the cube power is even worse. And that's the difference between the amount of decimal places or precision that you get between having your floats 24-bit or 32-bit.